Welcome to the fall semester of organic chemistry. This is Chemistry 2323, section 01B. You will see in a moment why I am emphasizing B. It's because it is a blended course involving face-to-face instruction and online. First, the introductions. I will be the instructor for this course. My name is Dr. Headley. I've been at the university for a number of years. I'm a professor here in chemistry, and my email address is shown here. And that is the preferred mode of communication. So whenever you have a question or you need a clarification to any aspect of the course, just send me an email. Next, let us concentrate now on the course description. So what will we be covering in this course throughout the course of this semester? We will be examining the structures of molecules. You may recall from your Gen Chem course that you can write the chemical formulas of compounds, but it does not give the bond-to-bond or atom-to-atom connection, the actual structure. In this course, we will emphasize that aspect. We'll also look at isomers. You may recall that isomers are molecules that contain the same chemical formula, but the arrangement of the atoms is different. Conformation, we'll see what that is. That's basically molecules or isomers that have the same atom-to-atom arrangement, but due to rotation around bonds, they have different conformation. Stereochemistry has to do with the three-dimensional arrangement of atoms in a molecule. Sometimes molecules look very similar, but because of the three-dimensional arrangement of the atoms in space are different, these two molecules are in fact different. Next, we'll also concentrate on the nomenclature. We have a specific system of naming molecules, and you'll see that's called the IUPAC, based on the International Union of Pure and Applied Chemists. So we'll study that. We'll also look at reactions. Of course, this is a chemistry course, so you'd expect to get reactions or to study reactions of different compounds. Mechanisms are basically an explanation of how reactions occur. This becomes very important in organic chemistry because different reactions sometimes give unexpected results, and an understanding of the mechanism will give us a better explanation of these unexpected results. We'll touch on spectroscopy, but that will be covered mostly in the lab. So for the first semester, we will emphasize the following that I've highlighted here. My approach to teaching organic chemistry is to communicate the concept, the content of organic chemistry, but equally important, I want my students to understand the concepts that are covered and also be able to apply these concepts to solve different problems. So we will learn different concepts, definitions, etc. And equally important, can you as a student, after learning these concepts, can you apply that to solve problems? So So that will be the emphasis of my teaching for this course here. So you'll see it throughout my course is the applied aspect of your understanding of the concepts in organic chemistry. Bottom line is, I really want my students to be able to use the tools of organic chemistry to improve your critical and creative thinking skills. So in other words, you should be able to be a better problem solver. Okay? As you know that in today's society, whatever your profession will be, medical doctor, dentist, researcher, academic instructor, we are all scientists and we're all problem solvers. So this course will be used to help you to become a better scientist. Let's look at an application here of that concept and application. So here is benzene. We haven't studied that yet, but here is ibuprofen that we're all familiar with. We're all familiar with this name here. We're not very familiar with the actual structure, but this is the structure of ibuprofen. So what we will do is, if given benzene as a starting material, can you as a student, of course at the end of the semester, design a way to transform benzene into a very important molecule, ibuprofen? We will study that. As you can imagine, there is not just one answer, not just one route for this to be accomplished, but there are several ways that it can be accomplished. So that is why I prefer to develop that aspect of your thinking and creative thinking so that you can get, so you will more than likely get different answers, and we will grade for different answers as we go through this course. Here's another example, DEET, that's an insect repellent. So can we go from benzene to DEET? And that's one of the aspects that we'll cover in this course is synthesis using the concepts and the reactions of organic chemistry to devise strategies to go from a starting material to a compound that is of use in everyday society. So, learning outcomes. So what I'd like for you guys to do is to, at the end of the course, to become better at critical and analytical thinking about various problems. We'll use this exercise to solve organic chemistry problems, but the technique that's developed will help you to solve problems in general. The process, the scientific process that's acquired will be used to solve problems in general. And that is what's important. That's one reason. Another reason for taking organic chemistry is, yes, you will learn some organic chemistry, but equally important, you will learn that scientific process or improve that scientific process to solve problems. So you become an improved scientist. Thus, a letter grade that's earned in my class does not only reflect your knowledge of chemistry, organic chemistry, but it also reflects your ability to solve problems scientifically and the ability to become better scientists. So that's my goal for the students of my class. Other aspects here, more specifically applied to organic chemistry, we will utilize a process called synthesis. So we'll go from a starting material, typically a simple compound, and we'll transform that by different reactions into target molecules, typically important target molecules, as we have seen in the previous slide, such as DEET and ibuprofen, etc. The other aspect is strategies. So in other words, you will come up with different strategies to carry out your synthesis or to answer your questions. So in other words, there will not just be one correct answer. There will be possibilities, which is what I am encouraging students to do, is to think of possibilities to solve problems. We'll apply those concepts to solving problems. As we said earlier, we'll solve problems by looking at the mechanism, how reactions actually occur, so that we can better understand and explain unexpected outcomes for reaction. As I mentioned earlier, the course is designed to improve your critical and analytical thinking skills, and for you to become a better problem solver by using the scientific process that you have acquired in this course. And lastly, before the course is done, we will have looked at hundreds of different reactions. As you can imagine, it's very difficult to memorize all these reactions. So you cannot rely on memorization to succeed in this course. You cannot memorize your way through this course, but you should be prepared to learn some concepts. You should be prepared to develop strategies to apply these concepts to solving problems. Instructional methods. As I mentioned earlier, this is a blended course, which means a blend between face-to-face instructions and online. So we will meet on Tuesdays and Thursdays as shown in the university schedule of classes. And I will also communicate to you the link for lecture videos that you need to watch. I'll say more in a second. But of importance is that in addition to meeting every Tuesday and Thursdays, every Thursday throughout the course of the semester, we will have either a quiz or a midterm exam. Notice it's face-to-face. It's not an online quiz or an online exam. It's face-to-face. So you'll have to physically come to class on Thursdays to take these quizzes and exam. More than likely, they'll be at the end of the hour-and-a-half lecture period. The format of the quizzes and exams will be multiple choice and written responses. Okay? The reason why I put multiple choice is because a lot of the aptitude tests that students take for professional schools, the MCAT, the DAT, the pharmacy test, etc., they're all multiple choice. So at least you get the experience of working through multiple choice questions. The final exam is just multiple choice, and it's a standardized exam that is given, that's written by the American Chemical Society. In terms of the instructions, so the links for the videos, which are YouTube videos for the course, will be emailed to students, and students are responsible for watching the videos in a timely manner while studying along in your textbook. Okay, so work your problems in the textbook, get your textbook and read along, and of course watch these videos. The videos are about 30 to 45 minutes in length, and they will be posted or communicated to you or emailed to you in a timely manner so that we keep abreast with the course syllabus. Lecture times. So the Tuesdays and Thursdays, those time slots will be used to discuss and explain concepts and answer your questions that come up while watching the videos or reading through the text. So during the lecture times that's shown in the university schedule, we will use those times to just have a grand discussion of concepts and give examples of aspects that you did not quite understand but needed a bit more information on. Grading. So at the end of the semester, you will get a letter grade. And that letter grade comes from these various aspects. The first is we'll have quizzes. As I mentioned, every two Thursdays, there'll be a quiz or a midterm. We'll have midterms. We'll have 3. We'll see in a second. And we'll have a final exam. So the quizzes, the average of all the quizzes will be 20%. Each midterm is worth 100 points and is 20% of your grade. We'll have 3 midterms, so that's 60% of your grade. And of course, we'll have 20% here from the quizzes, and the final 20% will come from your final exam. So as you can see from this, you will have to start working hard from day number 1, because a large percentage of your grade will be determined prior to the final exam. Again, let me just state that. A large percentage of your grade will be determined prior to your final exam. So start the course with a lot of energy, and make sure you do well for each quiz and for each exam. So here are the exam dates. So these are fixed, so make sure you put these in your calendars. The 23rd of September will be the first one, the October 21st, the second, November 18th will be the third, and the final exam, it's already scheduled and shown in the university schedule. I did not put the date, but if you click on this website here, this link, it will tell you the exact date. Of course, I will communicate that to you also just prior to the exam. No makeup exam. So if you miss an exam, you cannot make it up. If, however, you have a excuse, valid excuse, you can be excused from taking that exam. If not, you will get a 0. You should bear in mind, however, that if you miss an exam and have a valid excuse, the other exams that you have taken will be used in the computation of your final grade. Final grade assessment. So of course, as you know, the grade that's submitted to the registrar's office, or ABC's letter grades. So this is how we'll compute the letter grades. If the class average is around 77%, 76, 77, 78%, I will use these cutoffs, the standard cutoffs for your grades. So 90 to 100 A, 80 B, 70, etc. If the class average for any one exam or combined exams, if that class average is below 70%, I will compute a new cutoff which will be lower than these, and let you know what those cutoffs are after each exam, so that you know exactly your letter grade. Your grade status will be posted in D2L, because as you know, so at any point throughout the course, you can log into D2L and you will see your percentage in the course, your grade percentage, and you can convert that easily to a letter grade based on the percentage. Assessment. this is a very important aspect of this course because we have graders to grade your exams. So I will not be grading your exams by myself. We have graders who are graduate students and are chemistry majors. So they will be grading the exams. So what you need to do is, after you have received your graded exams, you need to look it through carefully. If you detect a grading error, you can in fact submit it to me, the instructor, for a regrade. Here's the process. You must be concise in writing a note to explain exactly what is the grading error. Typically no more than a couple sentences. In other words, don't write me a page, 2 pages. Exactly what the error is. Return your request to me no later than a week after the exams are returned. So since the exams will be given on Thursdays, I will get the graded exams back to you by the following Tuesday. So you need to get any request for regrade to me by the following Tuesday. There's only one regrade per midterm. You're allowed only one regrade per exam. In other words, at the end of the semester, if you recognize that you are missing a letter, if you're close to a letter grade and missing it by a percentage point, you cannot go back and dig up your old exam and submit them for regrades. Make sure you do it in a timely manner. There are no regrades for the final exam, as you can imagine, because it is a multiple choice and a standardized test that's written by the American Chemical Society. This is your textbook here. You will need it for this course because the video lectures are designed around this textbook. It is expected that you have a basic knowledge of D2L, as you all know that your grades and just about all announcements, etc., are all posted in D2L. Students must have the ability to scan written work. So I may ask you to upload a scanned document that you have written. So again, you need to get your phones and scan a document and be able to upload it to D2L if needed. A model set, a model set is required because I find it very difficult for students to understand some of these concepts without a model, because a lot of these concepts that we will be discussing deal with molecules in 3-dimensional space. So you'll have to get a good visual of these molecules to fully understand how they react and different properties of these molecules. Here's one website that I've seen that has a good model set, but you can check online or wherever you can find it, or even borrow a model set from a past student. You'll also need a periodic table. Go online, download a periodic table, laminate it. It's going to be yours, and you'll bring it to the quiz, you'll bring it to the exam. It's your tool, so you will need that throughout the course. You will need all the assistance you can get to succeed, so take advantage of them. First is take advantage of office hours. My office hours are shown here. I'm in room 337 of the science building. As I mentioned, my preferred mode of communication is the email. So send me an email if there are any questions, but use up the office hours. We're fortunate as a university to have different tutorial programs. One that I am very familiar with is the JAMP program. That's in the science building. So look at the website and get familiar with it and see if you can sign up for the CHEM program. But you will need, or you more than likely will need help in the form of tutoring, getting your questions answered throughout this course. It's very difficult to study organic chemistry by yourself. Extremely difficult. In general advice, have a positive attitude towards chemistry and especially organic chemistry. If you keep telling yourself that you hate chemistry, it's hard, you more than likely won't appreciate it and benefit from this course. It's not hard, it just requires a lot of work, consistent work. Notice, consistent work starting from day number 1. You cannot sit down and study all night before the exam and expect to get an A. I can tell you from experience, that's extremely difficult. Read ahead. Okay, so develop a consistent schedule. So make sure your schedule is consistent. Also, make sure you stick with that schedule. Read ahead. So in other words, try to stay ahead of the material. So whenever we discuss it, you are familiar. At least you've seen it. And it will be much easier. Practice, practice, practice. Work lots of problems. There are many problems in the textbook, and you can find on the internet. I'll give you questions for the tutorial. Just keep working problems. If you can't solve it, that's okay. Attempt it. And then come to our lecture discussion section, and we will answer those questions for you. Ensure that you understand the concept before you attempt answering a problem. Make sure you understand the concept that's being tested and make sure you apply to getting solutions. Get your questions answered. As I mentioned earlier, we have tutorial programs. Use the office hours. Even ask your peers, your classmates. They are sometimes very good at working at solving these problems. And again, nurture your critical and analytical thinking skills. Always think about ways of solving problems. That's how we become better scientists. Okay, as we'll see later on, we have another co-requisite for this course called Chemistry 201. Make sure you work through those questions. I'll say more in a second. The textbook has a companion website, and here it is. It's a very good resource. All the answers for the questions in the textbook are posted there. All the PowerPoints for the lectures are posted there. We have some multiple choice questions with explanations are posted there. So look it through. Look it through. It will be very helpful throughout this course. It is not a good idea to memorize solutions. So you'll see solutions for problems, but it's not a good idea to memorize them because the same problem will not be given. Granted, it may be similar, but if you do not understand the concept, you won't be able to solve even a very similar question. More advice: ask yourself how a question on the quiz or the tutorial or in the book can be rearranged to get a similar question or a test question. I'll be honest with you, that is exactly what I do. I take the quiz questions, I take the tutorial questions, I use the same wording, but I just change up the molecules. Because if you understood the concept behind these questions, you should be able to solve any problem that's similar. On the quizzes or on exam, be precise in your answer, please. It's science, it's a science course. So of course, as you know, we require or encourage scientific writing. So as specific as you can get with your answers, that's good. Discuss possible solutions with your classmates. Of course, Another alternative here is bring possible solutions to the lecture discussion sections, so we can discuss them and see how best they can be used to give possible solutions. And on the exams and quizzes, you'll be graded on what you write and not what you meant to write. So in other words, make sure that whatever you write, you're not communicating it to yourself, but you are communicating it to the grader, somebody else. Make sure the grader, myself, can understand what's written so we can grade it accordingly. Lastly here, as I mentioned, CHEM201 is the co-requisite for this course. There are 3 sections. You need to register for one. I'm pretty sure you guys have already registered. So the way we'll run that is each weekend I will post tutorial questions in D2L of your section of the course under the announcements tab. So by Sunday of this coming weekend, I will post tutorial questions. You are responsible to download these tutorial questions on a sheet of paper. You are responsible for providing solutions, written solutions. And again, these solutions, they don't have to be correct answers. I try to stay away from correct answers, but just provide answers. My aim here is to get you thinking. Come up with something. Bring them to your tutorial session. If that's done, you will get full marks for that, for attendance for that day, 100%. Okay, so once again, you've answered all questions or provided responses for all questions, and you attend your tutorial session for that week, you get a full credit. If you do not provide full responses, or you do not come to class without response, you will not get full credit, more than likely half or something below that. So try to work with that. Your first tutorial session will be posted next weekend, in this case, this weekend coming. So we'll start classes the week of September 6th, which is next week. Okay, I think this is the last one. Of course, yeah, we just got this announcement, as I mentioned in class. So of course, as you know, we're living in a very different time, and as the university has decided to do mandatory, notice keyword here is mandatory testing of all students, staff, and faculty. So this is information which I'm sure you guys have already received, but here's where you can go to get your testing done, the Morris Rec Center or the Alumni Center, and here are the dates. Make sure you get these done before the deadline. That's it. So have a great semester of organic chemistry. As you hopefully I've communicated to you, you'll have to start off really studying the material. I mean, with a strict schedule. Make sure you stick to that strict schedule, and work hard. It's not a hard course. It's just that it requires a lot of work. And let's face it, that's why we're here. One reason why we're here. The bottom line is that in the end, we will become better scientists, better problem solvers, which will better prepare us for the profession that you will be going into. Okay? All the best.